Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about types of chemical reactions. In this session, let us see about chemical equations. What does it mean by chemical equation? How it is represented? What is indicated in a chemical equation? These all points let us learn today. Okay? Chemical equations. The symbolic representation of chemical reaction with the help of symbols and formulae is called a chemical reaction or chemical equation. Okay? What it is? The symbolic representation of a chemical reaction with the help of symbols and formulae of the chemical substances involved in that reaction is called chemical equation. For example, if you see A plus B gives C plus D. If we consider this as a chemical equation, in this A and B are the chemical substances which are participating in the reaction. Hence, these A and B are called reactants because these are participating and they are getting reacted with each other. So these A and B which are participating in the reaction are called reactants. And here C and D are formed in this chemical reaction by the reaction. So these two C and D are called as products. The chemical substances which are formed in a chemical reaction as new substances are called as products. And in between these reactants and products, arrow mark is there. This arrow mark shows the direction of the chemical reaction, means in which direction this reaction is occurring. That is shown by this arrow mark. That means this A and B are reacting each other to form C and D. That is indicated by this arrow mark towards the C and D from A and B. This indicates A and B are reacting here and C and D are produced in this reaction. And in certain chemical reactions, certain extra conditions will be needed, like heating, electricity, or light, something else. Certain extra conditions to be needed, and even certain catalysts also will be needed for the formation of that reaction, for the formation of new products. So, what are the conditions if there are any in a chemical reaction? Those are mentioned on this arrow mark. For example, here A and B react each other on heating to form C and D. Then a triangle is mentioned on this arrow mark, which represents heating is necessary in this reaction. And in certain chemical reactions, certain catalysts are used. For example, hydrogen peroxide decomposes to form water and oxygen. So in that reaction, manganese dioxide is used as catalyst. So that manganese dioxide formula will be written on this arrow mark in that reaction. So like this, whatever the conditions necessary for the reaction to occur, those are mentioned on the arrow mark. Reactants are written on the left hand side and the products are written on the right hand side of this arrow mark. This arrow marks also represents can be pronounced as yields or to give. A and B react to give or to yield products C and D. In that way it will be represented. For example, let us consider one reaction. When hydrogen reacts with oxygen, it gives water. This reaction can be represented by using this chemical equation. Hydrogen plus oxygen reacting each other to give or to yield water. This is called chemical equation. But here we have written in words. But generally chemical equations are written by using symbols and the formulae of the chemical substances participating and being formed. So this equation between hydrogen and oxygen to form water also can be represented with their formulae like this. H2 plus O2 gives H2O. This also represents the same reaction what we have shown in the above. Hydrogen and oxygen reacting together to give or to yield water. So this is said to be chemical equation. In the first equation, words are used, and in the second one, symbols and the formulae of the substances are used to write the chemical equation. For our convenience, symbols of the substances are used to represent the chemical equation generally. Instead of writing hydrogen complete name, just we can write the same by using this formula H2, isn't it? So this simplification method is used to represent a chemical reaction which we call as chemical equation. So this is the chemical equation for this reaction mentioned above. In this equation we use symbols and the formulae of the chemical substances participating on being formed. Okay. Chemical equation is a way to represent the chemical reaction in concise and informative way. Yes. So by using the chemical equation, we can get all the information regarding that reaction. So what are the chemicals participating in the reaction? What are being formed in the reaction? What are the conditions of that reaction? This all information will be given based upon the chemical equation. So these chemical equations can be divided into two types. They are balanced chemical equations and unbalanced chemical equations. So in the chemical equation, as we said, number of the chemical formulae and symbols of the chemical substances participating and being formed are used. So if they are balanced on the both the sides, then that equation is said to be balanced chemical equation. If they are not balanced, then that is said to be unbalanced chemical equation. Okay, now let us see first about balanced chemical equation in detail. A balanced chemical equation has number of atoms of each element equal on both the sides of the chemical equation. Okay, so the chemical equation in which number of atoms of all the elements are equal on both the sides, then that equation is said to be balanced chemical equation. Okay, for example, consider this equation between zinc and hydrosulfuric acid. Zinc and sulfuric acid. When zinc reacts with sulfuric acid, it replaces hydrogen and forms zinc sulfate and hydrogen gas. So if you observe this equation, now in this equation, the number of atoms of zinc, hydrogen, sulfate ions or sulfur and oxygen are equal on both the sides. So it is a balanced chemical equation. It is said to be a balanced chemical equation. Why? Because the number of atoms of all the elements on the both the sides of the reaction are equal. Hence it is a balanced chemical equation. If you say number of hydro zinc atoms here, there is only one. Here also only one. So zinc atoms are balanced. And if you observe hydrogens, in the H2SO4 molecule, there are two hydrogen atoms. What about on the right hand side? Here also there are two hydrogen atoms. So hydrogen atoms are also balanced. And if you see sulfurs, there is only one sulfur at the left hand side. On the right hand side also there is only one sulfur. So sulfur atoms are also balanced. What about oxygen? Here there are four oxygen atoms and here also there are four oxygen atoms on the both the sides of the equation. So all the atoms of all elements are same on both the sides. Hence this equation is said to be balanced chemical equation. These balanced chemical equations are also known as stoichiometric equations. Okay. In generally, to understand the quantitative relation between the chemicals participating and being formed, always you have to take these balanced chemical equations only. Okay, from the balanced chemical equations only we can understand the quantitative relation between the chemical substances participating in that reaction and being formed in that reaction. For example, if you see here, one zinc atom reacts with one sulfuric acid molecule to form one zinc sulfate molecule and one hydrogen molecule. This quantitative relation we can say correctly only based upon the balanced or stoichiometric equation only. Okay, to understand that, always we have to take balanced chemical equations. Okay, now let us see another kind of balanced chemical equations, that is unbalanced chemical equation. If the number of atoms of each element in a reactants is not equal to the number of atoms of each element present in product side, then the chemical equation is said to be unbalanced chemical equation. For example, let us consider the chemical equation between iron and water. Iron slowly reacts with the water to form iron oxide and hydrogen gas. So this is the equation. Actually, in this equation, all are represented correctly only. What are the chemicals being reacting here and what are the chemicals formed in this reaction are represented correctly. But number of atoms of each element on both the sides of the equation are not equal. That is why this equation is said to be unbalanced equation. These unbalanced chemical equations are also called as skeleton equations. Skeleton equation represents simply the chemicals reacting on the chemicals formed, but not quantitatively correct. Those equations are called unbalanced equations or skeleton equations. So if you see in this example, number of atoms of elements are not equal on two sides of the equation or reaction. For example, on the left hand side, only one iron atom is present. See here, only one iron atom is there. While three iron atoms are present on the right hand side. See here, there are three iron atoms. But on the left hand side, only one iron atom is present. So, these iron atoms are not balanced. If we observe oxygen atoms also, there is only one oxygen atom on the left hand side, isn't it? But if we see on the right hand side, there are four oxygen atoms. So oxygen atoms are also not equal on both the sides of the equation. So even atoms of one element are not equal on both the sides, then the entire equation is said to be unbalanced chemical equation or skeleton equation. So in this equation also, iron atoms are not balanced and even oxygen atoms are also not equal on both the sides. Hence this equation is said to be unbalanced chemical equation. So from the unbalanced chemical equation, we can understand what chemicals are being participated and what chemicals are being formed in that reaction. But we cannot get the quantitative relation between them. How many atoms of one component reacting with how many atoms of another component. That we cannot understand from the unbalanced chemical equation. To know that in exactly, we have to balance these unbalanced equations first. Now, let us see how to balance these chemical equations. Okay, let us see balancing of chemical equations. The chemical equations must be written in accordance with the law of conservation of mass. So this balancing or quantitative understanding of these chemical equations will be based upon the law of conservation of mass. So according to this law of conservation of mass can neither be created nor be destroyed in a chemical reaction. Means mass will not be created in a chemical reaction and it won't be destroyed in a chemical reaction. Just it converts from one form to another form. So this represents the total mass of the reactants should be equal to total mass of the products formed. So to obey this law, the total mass of elements present in reactants must be equal to the total mass of the elements present in the product side of the chemical reaction. Okay. We always have to represent a chemical reaction by balancing the equation. Yes, as we said, to understand the quantitative relation between the chemical substances in a reaction, we always represent a chemical equation with a balanced chemical equation only. We have to represent the chemical reactions with balanced chemical equations only. Then only you can understand complete and accurate quantitative relation between the substances. Okay. Now let us try to understand the steps to be followed for balancing a chemical equation. So how can we balance a chemical equation? Now let us see step by step. Let us consider the same which you have seen just now. Unbalanced chemical equation, that is representing the reaction between iron and water to form iron oxide and hydrogen. As we know, this is not a balanced equation, isn't it? If you see on the left hand side, iron atoms are only one, isn't it? And whereas if you see right hand side, there are three iron atoms. So, number of iron atoms on both the sides of the chemical reaction are not equal. Hence we say this is an unbalanced chemical equation. Now let us try to learn how to balance this equation step by step. First, write the number of atoms of elements present in reactants and in products in a table as shown here, so that we can understand which atoms of which elements atoms are balanced, which are to be balanced still. So in this equation, iron atoms are there, hydrogen atoms are there, and even oxygen atoms. On the reactant side, there is only one iron atom, but on the product side, three iron atoms are there. In the same way, we have written here atoms of all the elements present in this equation, hydrogens and oxygens. So iron atoms are not balanced, oxygen atoms are also not balanced. Now we have to balance these. So let us balance the atoms which is the maximum in number on either side of the chemical equation. Say oxygen atoms, there is only one atom on the left hand side, but there are four oxygen atoms on the right hand side. So the oxygen atoms are maximum on the right hand side. Now the number of oxygen atoms is the maximum on right hand side. So to balance oxygen, we need to multiply the oxygen atoms on the left hand side by 4, because here there are 4 oxygen atoms. On the left hand side there is only one oxygen atom in the molecule. So we have to multiply this molecule with 4 on the left hand side. So the number of oxygen atoms becomes 4 on the left hand side also. To make it equal, we have to multiply this with 4. But remember here, we should not keep any numbers here or here. Only the total molecular formula should be multiplied with any coefficient which we are going to take here. Only here we have to write the numbers whichever we take. We should not write at the base on the right hand side, and we should not write in the middle also molecular formula. Only as a coefficient we can take the numbers. Now to make this oxygen atoms 4 on the left hand side also, we need to multiply this formula with 4. So the equation becomes like this. F iron plus 4H2O gives Fe3O4 plus H2. Now if you observe here, number of oxygen atoms on the left hand side is 4 and right hand side also 4. So oxygens are balanced with this. Okay, see, oxygens are balanced now. Now the number of hydrogen atoms became 8 on left hand side, which is more than that on the right hand side. How many hydrogen atoms are there now? In each molecule of water, there are 2 hydrogen atoms. Totally how many molecules it became now? By balancing oxygens, it became 4 water molecules. So from the total 4 water molecules, number of hydrogens became 8 here. But on the right hand side, still there are only 2 hydrogen atoms. So to make these hydrogen atoms balanced, we need to multiply the hydrogen on the right hand side with 4. See, if you keep here also 4, the total hydrogen atoms on the right hand side becomes 8. By this, hydrogen atoms will be balanced. So let us multiply this H2 with 4. Now see here, hydrogen atoms are also balanced. Oxygens are balanced, hydrogens are balanced. Still, iron is left. After that, number of oxygens and hydrogen atoms they became equal on both the sides. The number of iron atoms is 1 on the left hand side, while it is 3 on the right hand side. So still only iron is not balanced, because here there is only one iron atom on the left hand side. On the right hand side there are 3 iron atoms. To make it balanced, we need to multiply iron on the left hand side with 3. So if we keep here 3, the number of iron atoms on the left hand side also becomes 3. So we are doing that. So iron on the left hand side is multiplied with 3. By this, all the atoms are balanced. Now the number of atoms of each element becomes equal on both the sides. Thus, this equation becomes a balanced chemical equation. Okay. After balancing, the chemical equation can be written as this. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Observe once the number of atoms of each element on the left hand side and right hand side are being equal. Thus, this equation is said to be balanced chemical equation, or also called stoichiometric equation. So for understanding any chemical reaction, we need to take only balanced chemical equations. By the balanced equations only, we can understand the quantitative relation between the chemical substances. For example, let us take the same. From this equation, we can understand 3 atoms of iron combine with 4 molecules of water to form 1 molecule of iron oxide and 4 molecules of hydrogen. So this is a quantitative relation between the reactants and products formed in this reaction. This is correct. But if we take the unbalanced equation, from that we cannot get the accurate quantitative relation. Okay, that becomes wrong then. That's why always we have to use balanced chemical equations to understand the relations between the atom molecules or substances participating in the chemical reaction. Hope you understood. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos. You can visit our website aimstoday.in also for these recorded videos and for latest updates.